Now let us move on to solving another numerical problem from engineering mechanics, problem set 3.1, solution to 3.1c. But before I solve it, I must request you to go back to my previous video, that is in which I explained, that is in 3.1a, I explained Brignon's theorem. So let me first explain that once more, then I will come back to 3.1c, explaining 3.1c. So in 3.1a, how the Brignon's theorem principle I have explained in 3.1a. It was like this. Here is a force R, which is the resultant of a P and Q, two like parallel forces. And since they are parallel, the angle between P and Q is 0. So your R will be equal to P plus Q. And from the line of action of P and to the line of an action of Q, if I had drawn a perpendicular, and these two angles were alpha, then MC was equal to AC times cos alpha, and your CN was equal to your BC times also cos alpha. And the statement of the Brignon's principle was moment of R about C is equal to the algebraic sum of the moments of P and Q about C. Means the moment of this R about point C is 0, because the line of action of R is passing through C, doesn't have a perpendicular distance, so it is 0. And the line of action of Q is at this perpendicular distance from C to N, and the line of action of P from the point C has this perpendicular distance MC, and the line of action of Q about the point C, it was producing an anti-clockwise movement that was equal to Q times Cn, and the line of action of P about this point was producing a clockwise movement that was equal to P times this perpendicular distance MC. So I had written as R times 0, the perpendicular distance of R from the line of action of R from the point C was equal to Q times Cn minus P times Cm. So using the same principle, now let us move on to solving 3.1c. Now resolve the same force 4000 Newton. In the original diagram, the 4000 Newton was acting from point A to this side. We have to resolve this to a force P at point B and a couple. We have to resolve this force into a force and a couple, right? Representing the couple by force F acting along BB and CC. Now look at the explanation part of it. This original force 4000 Newton, which was acting at A to this side, this does not have any moment. The moment of this force about point A is 0, because the line of action of this 4000 Newton from the point A is at no perpendicular distance. Perpendicular distance is 0. So 4000 times 0 is 0. Now when resolved, we have to resolve this at B, means we have to take it to B, then resolve it into a force and a couple. So when resolved at B, this force resolved at B, it will be same 4000 Newton at B acting to this side. So what will be its moment about point A? The line of action of this 4000, when it is considered here, the line of action is at 2 units perpendicular distance. So its moment about A will be 4000 times 2 units perpendicular distance, 1 unit. So it is 8000 Newton meter clockwise. If this force is resolved here, means 4000 Newton to this side, 4000 into 2 will be a clockwise moment about point A. Now since earlier it was 0 when it was at A, now we have to make it 0 again. So we have to consider a couple. So earlier it was 0 when it was at A. So to make it 0, we need to have an anti-clockwise movement of the same amount. 4,000 into 2, that is equal to 8,000 Newton meter. Force into perpendicular distance, Newton meter. So therefore, so another diagram is redrawn for you. It has asked us to find a couple representing a force F acting along BB and CC. This is your BB, this is your CC. So along the direction BB, I consider 4,000 Newton to this side, and along CC, I consider another force 4,000 Newton to this side. And the line of action of CC and BB, they have a perpendicular distance of 2 units. So this perpendicular distance is 2 units. Now, so the couple, so due to this, the couple will be force times the perpendicular distance. And this will be anti-clockwise. This will be anti-clockwise. So the couple C is equal to 4,000 into 2, that is 8,000 Newton meter. So this anti-clockwise couple of 8,000 will balance this 8,000 Newton meter clockwise to make it 0, because it was initially 0 when 4,000 Newton was acting from point A to this side. So to make it 0, we need to have an anti-clockwise movement of 8,000. So this can be achieved by a couple as shown here, by considering a force 4,000 Newton along BB and another 4,000 Newton along CC. So that is all about.